Hi friends, this is Syed Reshma Sharif. In this video lecture today, I am going to discuss about basic principles of radar. It is very interesting topic, that is basic principle of radar. In this video, let us understand what is principle, how the radar works and all. Let us see. The radar working principle is very simple. Here, this is a radar. It transmits electromagnetic It transmits electromagnetic power, electromagnetic, as well as it examines the energy and it returns back to the target. These return signals are received again towards the position of a source. Then an obstacle is transmitted away. This is the working principle of radar. See clearly, let us explain. Here, this is a transmitted power, whereas this is radar. It transmits some kind of power and it reaches to the target. From target, again, it receives some kind of power and it reaches to the position of source. Then the obstacle is a transmission way. It forms a transmission way through the obstacle. Isn't it? This is the working principle of radar. Here the fundamental elements of radar and its block diagram. Let us see first of all what is the definition of radar. Radar is an abbreviation of radio detection and ranging. Let us see again what is the abbreviation of radar. R stands for radio, RA stands for radio, DA stands for detection and its ranging. Radio detection and ranging, RADAR. A system used for detecting and locating the presence of an object. This is an object, it is placed somewhere. Now, the system, it has to find this target location. For finding the detection of target and its range, that is called as a radar. It is used for detecting, locating the presence of an objects like ships, vehicles, aircrafts, etc. Not only ships, vehicles, aircraft, whatever the object that is placed somewhere. For finding this one, this radar system can be useful. By radiating electromagnetic signal in space, it is known as a radar system. Here, which kind of signals they are using? Electromagnetic signals. These are electromagnetic signals. If radar we heard means definitely here electromagnetic signals they are using in space for radar system. What is the definition of radar? Radar is an abbreviation for radio detection and its ranging. A system which is used for detecting and locating the presence of an object. It is known as a radar systems. Now, basically, radar is used to collect the information related to the object like target, like range and location by radiating electromagnetic energy and examines echo signals received. Now, we send some kind of signals and we receive back some kind of signal that is called as a echo signals. Echo signals means from target we are receiving those signals are called as a that is called as a echo signals. This is received towards the source side from target. With this we can form a path and we find where is the target placed. What is the principle of radar? A radar system operates in the way that it radiates electromagnetic energy into space and detects various aspects related to objects by analyzing the echo generated. When the radiated energy gets re-radiated by object, re-radiated means echo signals that which are coming back. That means reflected signals. This figure shows the complete basic principle of radar. See here, this is transmitter, this one is receiver. Here for transmitter receiver the same antenna is placed Okay, here this one is a target. Our target is aeroplane. Let us see. For example, here radar I am transmitting some kind of signals. It reaches to the antenna. From this antenna, um, it transmits some kind of signals. Okay, and those signals that are reached towards the target, and from target again here it receives echo signals. It is received by receiver antenna. From that it reaches to the receiver. From this we will find the location of here what the electromagnetic signals that are produced by the transmitter unit from the transmitter unit and radiated in the space by the radar antenna. Here with this radar antenna it transmitted some kind of signals towards the radar antenna, while the receiver performs extraction of an information from signal received by the radar antenna. Okay, we know where an electromagnetic wave is transmitted by the system, it reflects or re-radiates some of its parts on experiencing a variation in conductivity of medium. Okay, this medium is nothing but here free space. We are transmitting some kind of signals to transmitted antenna, isn't it? And it re-radiates signals back. Re-radiated signals are here nothing but echo signals, and reach are received towards the receiver. Okay, towards the receiver. This radar system receives echo signals with the help of an antenna in order to analyze the location of an object. Then we will find the location of the object. Here, for example, if target the ship is there, we are sending some kind of signal from that ship. We will receive back some kind of signals towards the source side. Okay, now the question arises how the reception of an echo signal can be determined, the range and location of the target. How we will find? Just we know the signals are coming back. The range specifies the distance between the target and the radar system. Which range? Range of the target. Okay, the range of an object is determined by measuring the time taken by the radiated signals to reach the object and come back to radar. And the location of the stationary object in the space is determined from angle point by antenna when the echo signals received of a maximum amplitude. For finding the radar range equation, for finding the range of the target, we need to find a radar equation. Here the term radar range equation, that is we are going to find. Till now what we discussed about the target block diagram of radar as well as working principle of radar, how it works. Okay, now it's time to find the radar range equation. Now what is radar range equation? Let us see. Here we have discussed previously basic principle of radar, isn't it? And how the radar is used for detection and location of an object in space. But the question arises that there are any limit which specifies the range up to which this detection is possible? Up to any limits? Let us see. So the answer for this question is there exist some factors that decide the range of radar, and those factors combinedly form the radar range equation. Those factors are completely formed as a radar range equation. Here the radar range equation is used to evaluate the particular range up to which the object or target detection is possible. The equation is related to various factors of radar systems like characteristics of transmitting and receiving antenna and objects as well as targets, and the effects of environment. Environment has some kind of effects or not. Sometimes it is a fog, sometimes it was rainy, like that. Okay, the radar range equation is very important aspects to show how much range up to the system can detect the target. Let us find. Now in this section we are going to derive the equation of radar. Here first of all Consider the transmitting power of an antenna. This is a transmitting power of an antenna. Okay. First of all, if we transmit power only now, this radar works. This is transmitting power of an antenna. Okay. Now, this transmitting power of an antenna, it is defined by, it is an isotropic antenna. Okay. Transmitted power P is equal to Pt by 4 pi r square. Okay. Here this r denotes the distance of an object from transmitting antenna. Okay, r denotes distance of an object from transmitting antenna. Okay, Pt denotes as maximum amplitude of transmitted power, that is of transmitting power. Okay, now let us see. Here we take P is equal to Pt by 4 pi r square, where Pt is a transmitted power, r square is a range between the target. Here the ratio of a transmitted power of an antenna surface of an imaginary sphere. Here r denotes as a radius of a sphere. Okay, 4 pi r square. That is a radius of a sphere. Its units is watts per meter square. Okay, usually radar system uses to directive antenna with narrow beam widths that directs the radiated power to the signal. Maximum it uses like this antennas. Okay, because for narrow beam width. Okay, the antennas gain specific power density of the direction of antenna. Power density in particular direction of an isotropic antenna is given by, thus G gain of an antenna is written by maximum power density by directive antenna by power density by isotropic antenna. Therefore, the power density of the directive antenna at the object is defined by Pt by 4 pi r square. Okay. Here we know that signal transmitted by radar intercepted by an object in the space, then the energy gets re-radiated in different directions. In different directions, the energy get re-radiated. Okay. And this leads to the reception of the parts of transmitted signal. That is, transmitted signals are nothing but echo signals. Okay. Here suppose we know that signal transmitted and the power density P we have to write. Okay. Now suppose P is the power density incident on an object and it is given by P is equal to Pt Gt by 4 pi r square into sigma, where the sigma denotes as a cross-sectional area of the object. Sigma denotes as a cross-sectional area of the. Here, suppose P is the power incident at an object, Pt Gt by 4 pi r square. Sigma is nothing but a cross-sectional area of a target. Okay. Here, so reflected power density at a radar system is given by Po. Reflected power means echo signals, that which is given by Pt Gt by 4 pi r square into sigma by 4 pi r square. That is 4 pi r square is nothing but area of a sphere. Okay, the antenna at receiving section of a system that captures the part of the echo signal reflected to the objects. However, the power received by an antenna will be the product of power incidence on receiving antenna into effective area. AE is here nothing but effective area. The power received, which is equal to power incidence power and its effective area. AE is given by A into sigma A. Okay. Here A is a physical area and sigma A is the antenna aperture efficiency. Now what we have to write? We have to substitute all this in PR. Power transmitted is nothing but Pt Gt sigma by 4 pi r square whole square into AE. Okay. Into AE. Then power PR is equal to Pt Gt sigma by 4 pi r square r to the power of 4 AE, where AE is a effective area of antenna. Okay. The distance beyond which an object cannot be identified. If this is an object, we cannot identify this object. This is of higher range. At this time, what we have to do, and it happens this happens when received echo signals becomes equal to minimum detectable signal, S minimum. The power received from the echo signals, that is equal to S minimum, that is minimum detectable signal. At that time, what we have to do, we have to substitute PR is equal to S minimum in this one. Okay, the value is R max. R, we have to find R max. This R moves here, this PR moves here. Okay, PR is equal to S minimum, in which case a received echo signals becomes equal to minimum detectable signal, S minimum. Then R max is equal to PT GT sigma AE by 4 pi R square S minimum whole to the power of 1 by 4. Okay. This is the equation known as radar range equation. It is very simple. Its complete equation is based upon, for this derivation, what we take here this power, transmitted power. From this transmitted power, we are taking 4 pi r square pt by 4 pi r square, whereas transmitted power by area of a sphere area. Okay, r denotes the radius of the sphere. From this we know that the power here G is nothing but gain. Gain is equal to maximum power density of the direct antenna by power density by isotropic antenna. Here maximum power density of direct antenna PT GT by 4 pi r square. Okay. Then what we have to do? We have to substitute. For incidence power, this is P, and this power PO is nothing but reflected power. In that, reflected power means some kind of sigma, that is received reflected cross-sectional area of a target, that is PT GT by 4 pi r square into sigma by 4 pi r square. Okay, now PR equal to PO in P0, P0 into AE. Okay, P0 into AE. AE is given. Then PR is equal to P0 PT GT 4 pi r square into AE. Okay. Now PR is equal to PT 4 GT sigma by 4 pi whole square r to the power of 4. So we have to find radar range, isn't it? Now we are sending all those terms in this side. What we will get? This PR here. Okay, R max is equal to PT GT sigma by 4 pi r square S min. Here, yeah, PR into AE, where power, maximum power PR is equal to the minimum detectable signal. At this case, S minimum, PR is equal to S minimum. Okay, at this time, what we have to do? We have to substitute PR is equal to S minimum. R is equal to PT GT sigma by 4 pi r square S minimum into AE to the power 1 by 4. This is a radar range equation. This is called R maximum PT GT sigma AE by 4 pi r square S minimum power 1 by 4. This is a radar range equation to find the target range. Okay, thank you for your watching. If you have any doubts regarding this, please comment me on my comment section.